Good afternoon, class. So at this point we're looking at differential calculus. The second video dealing with your calculus or your cubic function. So in the previous video we looked at exercise or examples 1 to 3, correct? So today we're going to look at example 4. Example 4 is on page. It would be nice if somebody can tell us then. Example 4 is on page. Why isn't it coming out here? Example 4 is on page. Okay, which page is it? 170? 3. Okay, so here we are told in example 4 that f of x we are told that f of x is equal to x cubed plus px squared plus qx plus r has an x-intercept of 2 and 0 and a point of inflection at 0 and minus 8. People, so for the point of inflection, how do you work out the point of inflection? Second derivative, and we set it equal to 0 and we solve for x. Here we are told that the point of inflection is at 0 and minus 8. So what we do is we know that this is a positive graph, so the graph first goes up then down. The point of inflection happens midway here, which is 0 and minus 8, and one of the points of intersection is 0 and 2. Okay? So from here we can already say that if the graph is going through 0 and minus 8, that is your mean value. Now say for argument's sake we didn't know that. Okay? Then what we say is if we'll substitute 0 and negative 8 into f of x, remembering that's the x and the y, we got negative 8 is equal to 0 cubed plus p times 0 squared plus q times 0 plus r. So r is of course negative 8. Okay. Then the point of inflection, if we take the first derivative, so I'm going to get 3x squared plus 2px plus q. That's your first derivative. Your second derivative will simply be 6x plus 2p. Okay. So with this information here, that the point of inflection occurs there, that means to say that f double dash of 0, which is that x value, is equal to 0. Okay. So we take that into account. We say since f double dash of 0 is equal to 0, so 0 is equal to 6 times 0 plus 2p, which implies that p is equal to 0 if you solve for p. So your r you got and your p you got. So that means to say my equation now reads f of x is equal to, just up a bit. Now means to say that f of x is equal to x cubed. Your p is 0, so that falls away. Plus q x minus 8. So what we still need to solve here? Q. Do we have another point on this graph? Yes, we have 2 and 0. So at this point we're going to substitute 2 and 0 into f of x. Now remembering again, this is an x and a 1. So 0 is equal to 2q plus q times 2 squared minus 8. So it's 2 cubed plus q times 2 minus 8. I think I said squared. It's not squared. So that means to say that 2 cubed is 8 minus 8 is 0. So 2q is 0, therefore q will also be equal to 0. So what's my equation? Therefore, we have f of x equals x cubed minus 8. Okay, is there any confusion there? I'm sure there's other ways could be calculated. Let's go to the second part of the question. It says sketch. So now let me just pull this down here quickly. The example 4 now tells us sketch f of x, f dash x, f double dash on the same system axis, showing all intercepts with the axis as well as the coordinates of the stationary point or points and the point or points of inflection. But we know that the point of inflection is only one point of inflection on your cubic function. Okay, that's where the graph goes, the swaps polarity from concave up to concave down. So if you're going to consider from the previous question, this function was x cubed minus 8. So when we work out our f of x, our x-intercept, we let y equal to 0. So 0 is equal to x cubed minus 8, so x works out to be 2. Y-intercept, we let x equal to 0. So we got f of 0 is equal to negative 8. So what we work out now is the point, the turning point. So f prime x is equal to, not double dash, but f dash x, f prime x is equal to 3x squared. We said equal to 0, that we drop, so x is equal to 0. We substitute that back into the function, so f of 0 is again minus 8. So what we notice is that the local max and minimum is the same value, which means to say it's also the point of inflection. When the maximum and the minimum, the local max and the local min is the same value, then the point of inflection will also happen at this 0 and minus 8. So I can draw that graph first. As we know that this graph is first going up then down. So the x-intercept is 0 and the y-intercept is 0. Okay? The point of inflection happens here. So what we do is we need to generate another point on this graph. Do we have to? No, we don't. Okay, so we know the shape of this graph. But it's going to be safer. Rather draw it. It's going to be safer for us. So what do we say? Let x equal 1. Okay, because this graph is going to look like that, going through 0 then. Yeah? So f of 1, of course, is going to equals 1 cubed minus 8, which is negative 7. Okay. So if you look at this graph, redraw this. Most of the business happening at the bottom. So it's going to go through a negative 8 here. And if x is 1, y is negative 7. And it's going through 2 and 0, which is there. So this is where the point of inflection occurs. So that part of the graph gets drawn, and then that is going to be 1 and -7. This is coming from that value there. Okay. So this is your f of x graph. Now let's look at your f prime x, your derivative function. Okay. So if you're looking at the derivative function of the graph, if f of x was x cubed minus 8, then f prime x is going to give you 2x squared. So if you work out our x-intercept here, what do you do for x-intercept? We let y equal to 0. The graph is smiling, it's a smiling parabola. So that is going to give us 0 is equal to 2x squared, so x works out to be 0. If you work out y-intercept, 3, absolutely. Thank you, Michael. So y-intercept, we let x equal to 0. So f of 0 is going to give you 3 times 0 squared, which is 0. So your x-intercept and your y-intercept is 0. So what do we do now? We say let x equal 1. So f of 1 is then equal to 3 times 1 squared, which is 3. So that point of contact is 1 and 3. The graph is going to go through like that. And that is f dash x. Okay. As you can see here, what's the significance there is that what's important to note at this point is that the point of inflection is also the turning point of the parabola. Okay. And then the last part of that graph thing, also for that f of x is equal to 3x squared, because we have done at this point your inverse functions, we could have used -1, 0 and 1. Okay, so if it's in that format, we normally use those values there. Okay, and then the next question is, next part of the question is double dash of x. So f prime of x was 3x squared, so f double dash is going to give you 6x. So we go x-intercept at y equal to 0, we'll get 0. Y-intercept at x equal to 0, we also get 0. So what do? We let x equal 1. So f double dash of 1 is going to be 6 by 1, which is 6. That point of contact is 1 and 6. There's 1 and 6. And of course I take a ruler, and you'll see it will be an increasing linear function. And that is f double dash of x. Again you'll see that the x-intercept of your second derivative linear function is also the point of inflection, the x value at which the point of inflection occurs at. Okay. And again remember when we explained that if the function was a cubic function looking like that, which is this case in this example, then f prime x will be a smiling parabola, and f double dash of x will be a increasing linear function. And as you can see, that's a relationship that exists there. You'll see that coming over and over and over again. Okay. So that is example 4. Let's look at example 5. Example 5 is on same page, 173. Right, so here we are told consider the function g of x equal to x cubed plus ax squared plus bx plus c, which passes through the origin. So if this graph is going through the origin, what do we know? Not everybody at once? There's one person? Yes, the c value is 0. I'm telling myself this is the minus in my head. The c value of course is 0. Okay. It's sad, yes, it's very sad. You think that you guys are grade 12 supposed to be on top of your game at this point. It's sad to see that nobody could have answered the question. But anyway, it's passing through the origin and has a tangent. And as a tangent given by the equation y is equal to 24x minus 54 at x equal to 3. What can we derive from there? Many things, yes, many things. We can derive that if this is a equation of a tangent, what I do is I always draw this here to give me an idea of what's happening. So there's a 3 and some y value. The equation of your straight line is y is equal to 24x minus 54, and now the cubic function is g of x is equal to x cubed plus ax squared plus bx, in this case plus 0. Okay. So what does that mean to say? That means to say that that is your gradient, people. That's your gradient. So that means to say that if dash of 3, if prime of 3 is equal to 24. Vital information. Why? Because when they ask you to determine the equation of the tangent, what we do? Apply the first derivative, we substitute the x value in at that point, and we get the gradient out. Here we have to work in the reverse. Why? Because we are given the gradient. We are given the x value at which the tangent makes contact with the cubic function. Okay, so we'd have to consider then that f prime of 3 is equal to 24. Okay, first question, determine the values of a, b, c, showing all necessary calculations. So let's go. Number 1. Firstly, the c value. So you say you're going to substitute the origin, which is 0 and 0, into g of x. If I do that substitution, therefore c will give you 0. Okay. So my equation now reads g of x is equal to x cubed plus ax squared plus bx. Okay. Now coming back to this here, this fact. Okay. As you can see, there's two unknowns at this point, which is a and b. Not so. So what must we do? We must end up with two equations so that we can do simultaneous equations. Okay. So what we do is we apply the derivative. Is actually g here. Sorry about that. So we're going to apply g prime x is equal to 3x squared plus 2ax plus b. Now this comes into play, no? G prime of 3 is 24. So I now say g dash of 3 is equal to 3 times 3 squared plus 2a times 3 plus b is equal to 24. So what I'm going to do is I'm going to make b now the subject of the formula. Okay? So we're going to make b the subject. So drop that. So b is equal to negative 6a. That is of course 9 times 27. So it's negative 3. Is that correct? Huh? What is 24 minus 27? There should be negative 3, no? And that is equation 1. So of course, as I said, I need to set up another equation to get an equation 2 out of now. But where am I going to get the equation 2? You see this point here. Okay? You see this point here. Okay? What is that shorting? You're shorting a y value. Not so. But that is also the point where the tangent cuts the cubic function. Can you see that? That's also a point of intersection. Yes, well done. It's a point of intersection, yes. So what do? If you substitute 3 into this equation here, we will get the corresponding y value out. Can you see that, people? So we're going to substitute x is equal to 3 into the tangent to get the corresponding y value out. So we have y is equal to 24 times 3 minus 54. 24 times 3 is something with a 2, 72. What's 72 minus 54? Almost 18, I think it's 18. Just check there.
18.
Okay. It's 18, yes. So what does that mean? This point of contact is 3 and 18. Can you see that, people? So what am I going to do now? I'm going to substitute 3 and 18 into this g of x function. That is how I will generate my second formula. My second equation. Remembering again, that's the x and the y. Okay, and g of x, of course, is your y. So we have 18 is equal to 3 cubed plus 8 times 3 squared plus b times 3. 3 cubed is 27. What is 18 minus 27? Should be negative 9. Just check.
Yes.
Negative 9 is equal to 9a plus 3b. So what do? Is I divide throughout by 3. Okay? So that's going to give us b is equal to negative 3a minus 3. If I divide throughout by 3, I get negative 3 is equal to 3a plus b. I'm taking that over the equal sign as well. And this is equation 2. I didn't have to take that a over as well. Okay, as you can see, you can do simultaneous equations. Alright. So now we're going to substitute equation 1 into equation 2. Or we can equate the two equations, which is the same thing. Okay. So let's go. It's going to be negative 6a minus 3 is equal to negative 3a plus minus 3. Okay. Okay, solve for a here. So that's going to give us negative 3a is equal to 0. So a is equal to 0. Okay. So what do we do now? Now we substitute that back into any one of the two equations. Therefore b is equal to negative 3 times 0 minus 3, which is negative 3. Yes? So b is minus 3, a is 0, and c is 0. Okay. What's wrong, people? Right. And those were the values that they gave us initially. Remember when they asked you prove that or show that, we can't use those values in your calculation. You must just input with those values. Okay. I'm going to take this off so you can keep the main question in focus. Let's pull this up here a bit. Oh, that was only given in the second part of the equation. So that basically confirms my calculation, and my calculation is correct. So my equation now reads g of x is equal to x cubed minus 3x. Okay. Let's look at question 2.1. 2.1, determine the equation of the tangent to G, which is parallel to the tangent at x is equal to 3. People say, if lines are parallel, what do we know? Gradients are equal. So it could be that this equation that I've drawn in here could have been on that side, and the equation that they're looking for could be this one that I've drawn here initially. Can you see that, people? So just remember that if lines are parallel, gradients are equal. So that, with that in mind, you can then say the equation is y is equal to 24x plus c. So to calculate the value of c, I need to know the x value at which that point will, or the straight line or the tangent will cut the cubic function. Okay. So importantly here, we have the gradient, so we know that g prime of x equals 3x squared minus 3. What is this? 3x squared minus 3 is the general gradient anywhere along the curve. Okay? So what we do is we're going to substitute, or we're going to say that if lines are parallel, the gradients are both equal to 24. So I then say g prime of x is of course equal to 24. So 3x squared minus 3 is equal to 24 when we solve for x. So 3x squared is equal to 27, divided by 3, take the square root thereof. So x is equal to plus minus 3. Okay. Why do we have two values for x here? Because there's 2 points on this cubic function where it will have a tangent gradient of 24. Namely 3, which we know already, and this point here, which is minus 3 and some y value. Okay. How do we get that y value? By substituting the x value of minus 3 into g of x. Okay. So when we do the substitution now, we now say g of negative 3 is equal to negative 3 cubed, which is negative 27, minus 3 times negative 3, which is 9, which is an answer of negative 18. Okay? So this point is going to, of course, be negative 18. But have you answered the question? No, the question says determine the equation of the tangent. So what do we do now? Since this is the point of negative 3 and negative 18, we'll substitute that into your equation of that line. So negative 18 is equal to 24 times negative 3 plus c. So c works out to be negative 18 plus 72, or 24 times negative 3. It's supposed to be positive now. 54. So therefore, the equation is y is equal to 24x plus 54. Another question that could be asked here is that if this tangent is actually extended here, okay, you see this graph will go up. There will be again a point on this curve where the tangent will cut the cubic function again. Okay, now how do we actually work this out here? Is by working out the points of intersection, where we set the tangent equal to the cubic function. By doing that, we will then be able to get that point of intersection. Okay. But that question is not asked often, but basically that's how you work that question. That's what's in the answer. In the next question, they ask you to determine and classify the stationary points of G, showing all the necessary calculations. I'm going to draw this down here. So we work out if g prime x is equal to 3x squared minus 3. We say that equal to 0 for the x values of the turning point. So x squared is equal to 1. So x equal to plus minus 1. So the turning points, of course, your coefficient, or the leading coefficient of that expression is positive. So the graph first goes up then down. So that is where x is equal to negative 1, and of course x is equal to 1. So the point itself, the corresponding y value, I substitute that x is equal to minus 1 back into the function, so it's negative 1 cubed minus 3 times minus 1. So that gives you negative 1 plus 3, which is 2. So the one point of contact is negative 1 and 2. Okay, and the other one is of course g of 1 is equal to 1 cubed minus 3 times 1, which is equal to negative 2. So this point here is going to be 1 and negative 2. Therefore, your local maximum will be at negative 1 and 2, and your local minimum value will be at 1 and negative 2. Okay. That sum is normally worth 4 or 5 marks. Okay. Then in 3.2, determine the point or the points of inflection. So how do you work out the point of inflection? You work out our second derivative. Okay. So you say g double dash of x is equal to, where's g dash of x here? So it's going to be 6x, and I said equal to 0 of course. Drop that, so x equal to 0, g of 0, it's going to give you an answer of 0. So the point of inflection, which is this point here, occurs at 0 and 0. Okay. And the next question says sketch the graph of g. So let's sketch this graph quickly. So 2.4. Okay, so it's a y. Graph we will be doing this. Okay, and the point of inflection happens there, which is at the origin. The turning point, of course, is negative 1 and 2. The y value of 1 and minus 2. Surprisingly, they didn't ask you to work out the x values here, no? Classify the stationary points. Okay, they just didn't ask us at this point. Sketch a graph showing the intercepts with the axis. Okay, so I still need to work out my x-intercept. How do you calculate your x-intercept? Sorry? We let y equal to 0. So x-intercept, you will let y equal to 0. Okay, I just need this again. X-intercept, we let y equal to 0. So we got 0 is equal to x cubed minus 3x. We take out x as a common factor. Remember, you can't divide by x or variable. So that will be x squared minus 3. So x is equal to 0, or x squared minus 3 is equal to 0. So x squared is equal to 3. Get rid of the square root, don't forget plus minus. So x equal to plus minus the square root of 3. Okay, so of course that's going to be negative root 3, and of course positive root 3. The y-intercept at x equal to 0, of course will go through that origin. Okay. So sketch the graph showing the intercepts of the axis as we did there, the coordinates of the stationary point to points, the point of inflection which is also there, and we just showed all the necessary calculations as needed. Okay. Okay, so that basically brings us to the end of calculus. Okay. And with that you should be able to conclude exercise 13 on page 174 and 175.